Okay, so with number 11, we want to find the value of x at 5 and x at 6. We want to know, does the intermediate value theorem guarantee a 0 between those? So what the intermediate value theorem does is it says, okay, you have two numbers, two x values. So in this case, we're using 5 and 6. Okay, so it says you're going to plug those in, you're going to get a y value. If one of those y values is positive, so some positive number, and the other y value is negative, so it's below the line, so this is a positive number, this is a negative number, then that guarantees you that at some point this line had to cross and go past 0. So you're checking the sign. Okay, the number doesn't actually make that big of a difference, but if the signs are different, one of them is positive, one of them is negative, the only way to go from positive to negative is that at some point you have to get 0. Now, we're not looking at the graph, but that graph could do something like this. So if I'm doing the intermediate value theorem, I can have 5 and 6, for example, and then that graph could go down and come back up. So if you do intermediate value theorem and either they're both positive or they both could be negative, it doesn't matter. If they have the same sign, then we just say we don't know, or there's not guaranteed to be one, like we don't know for sure. It could happen, but we just don't know from using this theorem. So this theorem is looking for different signs on whatever values you use. If the signs are different, you know 100% that there's a 0 between there because you went from positive to negative or vice versa, negative to positive. If the signs are the same, both positive or both negative, then intermediate value theorem is inconclusive, like you don't know. So we can do this with synthetic. We can also do it by hand. I will do both. I'm sorry, we can do it by hand, which is synthetic, or with the calculator, which I want to do both. I'm going to show you. It's pretty fast with the calculator. I'm going to turn it on, go to y equal, clear this out. I'm going to graph this equation. Negative x to the third plus 5x squared plus 6x plus 9. We're going to go to the table. Second graph to see the table. We're going to go to 5. Here's 5. I get a value of 39. And then at 6, we get a value of positive 9. So in this example, we get both the same sign. They're both positive, so we're not guaranteed to get a 0. However, I do want you to be able to do these by hand as well. So I'm going to do these with synthetic division as well. Shouldn't take very long. So 5 is my little half box number. We're not missing any terms. We got 3, 2, 1, 0. So negative 1, leading coefficient 5, 6, and then 9. Bring that first term straight down. Negative 1 multiplied by 5, negative 5, combined you get 0. 5 times 0, we get a 0, combined you get a 6. 5 times 6 is 30, combined you get 39. So that last value is your answer, which is what we have in our box already. And then I'm going to do it with 6, negative 1, 5, 6, and 9. Bring that first number straight down. 6 times negative 1, negative 6, combine negative 1. 6 times negative 1, negative 6, combine 0. 6 times 0 is 0, combine, and you get 9. So you get 39 and 9. Okay, both ways are pretty quick. And so are we guaranteed a 0? No, we are not. Doesn't mean that there's not one. It just means we don't know. And then number 12 wants us to use synthetic division to determine whether -4 is an upper bound or lower bound of the real zeros. Okay, so since we're using a negative number, okay, negative number would only be possible to be a lower bound. Okay, negative numbers are lower bounds, positive numbers are upper bound. So what we're going to do, we're going to do synthetic division with this one. And we're going to see at the last row is changing signs. So we have x to the 4th plus x to the 3rd minus 19x squared minus 49x minus 30. And we're going to use -4 as our little box number. Now we have 4, 3, 2, 1, 0. So we have all our terms. So leading coefficient is 1, 1, -19, -49, and then -30. All right, so bring the first number straight down. -4 times 1, -4, combined, we get -3. -4 times -3, positive 12, combined, -7. -4 times -7 is a positive 28, combined, and we get a -21. And then -4 times -21 is going to be a positive 84. And then combine, and we get a positive 54. Okay, so we went from positive, negative, and then it stayed negative. So right here I could have stopped. Okay, but I just went ahead and did the whole thing. So positive, negative, this would have needed to be positive, and then that came out negative, and that would have been positive. So had this been positive, that could have been a lower bound. But since it is not, then that means it is not a lower bound. So we're going to say no determination can be made because it's not an upper or lower. That's the only one that we could choose that would make sense.